First, introduction, from lists to grids. So far, we have learned one-dimensional 1D arrays. These are perfect for storing simple lists. A list of scores, a list of ages, or a list of characters, a string. But what if we need to store data that isn't a simple list? What if we need a grid, a table, or a matrix? Think about a tic-tac-toe board, a chessboard, or a spreadsheet with rows and columns. To store this kind of data, we need two-dimensional 2D arrays. Second, what is a 2D array? A 2D array is simply an array of arrays. A 1D array is a row of elements. A 2D array is a collection of those rows, stacked on top of each other to form a grid. It has two dimensions, rows and columns. Third, declaration of 2D arrays. To declare a 2D array, you must provide two sizes in two sets of square brackets. Data type array name, number of rows, number of columns. Example, this code declares a 2D array named matrix. It has 3 rows. It has 4 columns. The total number of elements it can hold is 3 times 4 equals 12 integers. Fourth, accessing elements, double indexing. Since 1D arrays use one index, array sub I. A 2D array requires 2 indices to access an element. Array name sub-row index sub-column index. Just like 1D arrays, 2D arrays are zero-based for both rows and columns. Rows. The first row is index 0. The last row, in an array with 3 rows, is index 2. Columns. The first column is index 0. The last column in an array with 4 columns is index 3. Example. Using our integer matrix sub-3 sub-4, matrix sub-0 sub-0 equals the element at the top left corner, row 0, col 0. Matrix sub-1 sub-2 equals the element at the second row, third column. Matrix sub-2 sub-3 equals the element at the bottom right corner, row 2, col 3. Fifth, initialization of 2D arrays. You can initialize a 2D array when you declare it using nested curly braces. Each inner set of braces represents one row. Example, a 3 by 2 matrix, 3 rows, 2 columns. MyGrid sub-0 sub-0 is 10. MyGrid sub-1 sub-1 is 40. MyGrid sub-2 sub-0 is 50. Sixth, full code example. Let's see it in action. Expected output. Element at sub-1 sub-2 is 23. Element at sub-0 sub-0 is now 99. Seventh, conclusion and next steps. Today we learned that 2D arrays are arrays of arrays, perfect for storing grids or matrices. We access elements using 2 zero-based indices, row, column. This is the last lesson in our section on arrays and strings. In the next and final part of this section, 4.06. Exercises, no answers.